So we spent the last couple of days talking about logarithms, and today is the day we're going to apply them to sound energy when we talk about decibels. So a reminder that most times when people talk about how loud a sound is, they're going to measure that in decibels. So what are they? How do they relate to logs? And how do we calculate and work with them? Okay, so we have a chart here. I think I showed this before. These are showing you common decibel readings for some sounds that you might be able to relate to. So it's a good idea, if you haven't already, to make sure you have this chart. Okay, I want to start with what we already know about intensity. So we've done this already for light. You find intensity by doing the power of the source divided by the area of the sphere that the energy has spread out into. So if you had a 40-watt speaker and it's spread out into an area of about 28.3, which is about a 1.5 meter radius sphere, you would get an intensity of 1.41 watts per meter squared. And although that is a perfectly valid unit for measuring the strength of a sound wave, it is not the unit that is traditionally used by people all over the world. Instead, they work in decibels. So let's see how these are going to work out. So be careful. Decibels is going to sound a lot like what we just did. So this is the intensity of sound. And when we talk decibels, we talk about the intensity level, the intensity level of the sound. And you start with the exact same process that we already know how to do for light. And we get an intensity of 1.41. That is not the intensity level, that is the raw intensity. Okay, I want to take a step back and make sure you guys remember that humans cannot hear all frequencies. Some frequencies are too high and some frequencies are too low for the human brain to pick up. The same is true for the loudness of sounds. So there is a minimum sound. Anything lower than this, humans cannot pick up. And again, this will be different for different people, but the number that you'll traditionally see is an intensity of about 1 picowatt per meter squared. 1 to the negative 12th watts per meter squared. Any less energy than that is not going to be enough energy for us to actually register it as a sound. Again, you can have sounds that are softer than that, but people won't be able to pick them up. This is going to be our reference intensity. I0. That's what we're going to use as our reference when we calculate decibels. Okay, so here's how you're going to do it. The intensity level goes by the letter B. The raw intensity goes by the letter I. And the reference intensity we're going to use is 1 to the negative 12th. So what you're going to do is you're going to take the actual intensity, you're going to divide by the smallest intensity that humans can hear, and then you're going to take that and you're going to take the logarithm of that number, and that will give you intensity level. So let's say, just for instance, that you had an intensity of 1 to the negative 12th. If you divide those two, you're going to get a fraction equivalent to 1. When you take the log of 1, you get 0. That will be the starting point for sounds that humans can hear. So if the intensity level is 0, that is like the softest sounds humans can hear. Once we get higher intensity, so if we had an intensity, let's say, of 1 to the negative 11th, we would divide these and we'd get 10. You would take the logarithm of 10 and you'd get 1. What does 1 mean? 1 means that's the intensity level measured in bells. All right? In decibels, that would be 10 decibels. Remember, the deci is a metric prefix, meaning a tenth of. So 10 decibels is equal to 1 bell. All right, so let's just try this out. You're going to say, what is the decibel of a sound with an intensity of 1 watt per meter squared? So we plug in 1. We plug in 1 e to the negative 12th. We divide these two. We get 1 e to the positive 12th. We take the logarithm of that, and we get 12. That's 12 bells, which is 120 decibels. All right, so this is how we find our decibels, by taking the log of the ratio of I to I0. Remember, from our log identity, sometimes it might be easier, since we're doing a division, to do the log of the top number minus the log of the bottom number. The bottom number will never change. So you're going to get log of the intensity minus the log of 1 e to the negative 12th. This will be log of the intensity minus log of e to the negative 12th is going to be negative 12. So in essence, you could write this as the log of I plus 12. That may make some of your work easier. If you want, you never have to do that. You could just divide them and then take the log. Okay, so I'd like you to figure out the intensity level of a sound that has a power of 0.005 and is 6 meters away from you. So you're going to do I equals power over 4 pi r squared. Once you get the I, you're then going to do either the log of I plus 12, or you're going to do the log of I divided by I0. Remember, when you get your answer, it's in bells. You need to multiply by 10 to get it into decibels. So show me that you can work through that calculation. I also want to make sure that you can work backwards. So it says calculate the power of a train whistle using the information from your decibel chart. All right, so we're going to go back to the decibel chart. We're going to find the train horn at 500 meters is 70 decibels. All right, so let's jump back. So 70 decibels is equal to 7 bells. We then write our formula. And you could use either version. You plug in 7 as the level. Hopefully remember what has a log of 7. So this would be 1 e to the 7th equals I over 1 e to the negative 12th. You then cross multiply, and you get I equals 1 e to the negative 5th. We then use power over 4 pi r squared. It said that our train whistle was 500 meters away, so we plug this in as our I. And we plug 500 in as our distance, and we solve for power. So hopefully you can work through and find the power of the train whistle.